Hey, welcome to our notes for the slope of a line. This is review from Algebra 1, so we're going to go through it pretty quickly. We're going to begin on the front here with slope-intercept form of a line, y equals mx plus b. And in that form of the linear equation, the slope is the m. It's the coefficient on our variable x. If we're given 2 points on the line, x1, y1, x2, y2, then we can use the slope formula that calculates the difference in the y's divided by the difference in the x's, and that finds the rise over the run, which is the slope. Okay, we're going to learn this little song to help us in finding the slope between 2 points on a graph. If the points we're passing through are 2, 1 and 6, 9, we need to pick which one is going to be x1, y1. So I'm going to choose 2, 1 to be my x1, y1, and I'll choose then my second point, 6, 9, to be x2, y2. Okay, then the way that this song goes is where's the slope? Where's the slope? Rise over run, rise over run. Difference of the y's. And now we're going to subtract the y's. 9 minus 1, that's y2 minus y1, over difference of the x's. So we're going to subtract the x's. 6 minus 2, that's x2 minus x1. Simplify. So 9 minus 1 is 8, and 6 minus 2 is 4, and 8 divided by 4 is 2 over 1. 2 over 1 then is the slope of the line that passes between the points 2, 1 and 6, 9. So does it matter which point you use as x1, y1, and x2, y2 when you're finding the slope of a line? So in this example, let's use 2, -1 as x1, y1, and then we'll use the point 1, -5 as the x2, y2. Then we'll do the same formula for slope, but we're going to switch. We're going to make this 1, -5 be our x1, y1, and we'll have the 2, -1 be the x2, y2. So when we perform those calculations, right, using the alternating points as the x1, y1, both situations we end up with a slope of 4. So it doesn't matter which point, the 1, 1, or the 3, -5, you choose to be your x1, y1, and which you choose to be your x2, y2, you'll get the same slope either way. So you're going to pause the video and calculate the slope for A, B, C, E, or just A, B, and C rather. And then when you've calculated the slope, if it is a positive slope, indicate that the line is rising. If it's a negative slope, indicate that the line is falling from left to right. If the slope is 0, then your line is horizontal. And if your slope is undefined, which happens when you're dividing by 0, then your line is vertical. And you can resume the video once you've calculated your slopes for A, B, and C and check to see how you did. So in example A, we're taking -5 minus 1, right? That's our y2 minus y1. And we're dividing that by 3 minus 1, we get -6 over 2, which is -3. Since this is a negative slope, the line is falling from left to right. It's a decreasing slope. In example B, we're taking 9 minus 4 divided by 2 minus 2. 2 minus 2 is 0, and we cannot divide by 0. So this slope is undefined. That's indicated by a 0 with a slash through it. That symbol means undefined. And since it's undefined, the line is vertical. In example C, we're going to subtract 2 minus 2 divided by the quantity 5 minus -5. And 2 minus 2 is 0 in the numerator. 0 divided by anything is 0. And since the slope is 0, this is a horizontal line. Now in example D, we have an equation in terms of x and y. We're going to put this equation into slope-intercept form so that we can identify the slope. So I'm going to start by distributing this 2 over the parentheses. So I have 6 minus 2y is equal to 4 minus 12x. I'm trying to get the y by itself, so I'm going to move this constant over to the other side. So now I have a negative 2y is equal to negative 12x, and then 4 minus 6 is a negative 2. And to get this y by itself, I'm going to divide each of these terms by negative 2. So that leaves me with a y equal to negative 12 divided by negative 2 is 6. So I have a 6x, and then a negative 2 divided by negative 2 would be plus 1. And the slope of the line is the coefficient on the x, right? That's the m in mx plus b. And since the 6 is positive, that tells me that this line is rising from left to right. So it rises or increases from left to right. Okay, go ahead and pause the video. Try E and F on your own. You want to put those into slope-intercept form, y equals mx plus b, and then identify the slope and determine if the line is rising, falling, horizontal, or vertical. And then you can resume the video when you're ready. So in E, we start with 2x minus 3y equals negative 15. I'm going to subtract 2x from both sides, and now I have negative 3y is equal to negative 2x minus 15. I'm going to divide all of these terms by that coefficient of negative 3. So now I'll have the y by itself. A negative divided by a negative is a positive, so that's a positive 2/3 x. And then negative 15 divided by negative 3 is a positive 5. Since that slope is the coefficient on the x, that's a 2/3, it's positive. That tells me that the line is rising from left to right. So in example F, we're starting with 5 minus 3y equals 2y minus 15. And I'm going to try to get this y here on the left by itself. So I'm going to subtract this constant of 5 to the other side. So minus 5 from both sides leaves me with a negative 3y equals 2y minus 20. Okay, now I can think about this a couple of ways. I could divide everything by negative 3 at this point to get the y here by itself, or I could take this 2y and subtract it to the other side. I think that's what I'll do. So I subtract the 2y from both sides. Now I have a negative 5y equal to negative 20. Then I'm going to divide that coefficient, negative 5, from both sides, and that leaves me with a y equal to 4. Since there is no x in here anymore, right? There's no x. That means it's a 0x. And 0x is a slope of a horizontal line. So m is 0 and the line is horizontal. We could have been able to tell that even before we started this equation, noticing there is no x in here anymore. There's only y's. So this would have to work out to be a horizontal line.